Welcome back, students, for our second lecture. If you remember, in our previous lecture, we have seen what do you mean by axial force, what do you mean by shear force, what do you mean by bending moment, and what are the sign conventions of it. And basically, we have seen what do you mean by analysis and what is the role of axial force, shear force, and bending moment in analysis. Today, we will consider in this lecture types of supports, then we will consider types of loads, and we will consider types of beams gradually because we are going to encounter about these terms quite often that not. So first type of support we know, all of us know, is a hinged support. A hinge support. The first type of support we encounter generally is a hinge type of support. Hinge type of support. Okay. Another support is a roller support, which is indicated like this, or which is indicated like a simple roller and a beam kept over it. Hinge support or roller support. This is roller support. Hinge support, roller support. I hope you must be knowing about it. You must have done it in your preliminary course in structural mechanics in our earlier semesters. And another type of support is a fixed support. Is a fixed support. Fixed. It is indicated like this. Fixed support. We are going to encounter these terms later. Let us understand the meanings or the uh, other aspects related to the supports at a later stage as and when they will be there. I will be explaining, but let us understand the basics of these supports. And now one more joint is there that is not considered as a support, but it's a free joint. So another type is a free joint. A free joint. Free. So, my friends, let us understand what are the various types of reactions for the supports. Each support will offer two reactions, one along the support, other perpendicular to the supports. So, hinge support, two reactions. The number of reactions for hinge support at present, since this is the very preliminary course, let's remember to remember these simple things about the support conditions. The roller support will offer only one reaction, which is perpendicular to the roller. So roller support will offer only one reaction. It's not necessary that roller support should offer always a vertical reaction. Let us imagine that a roller support is inclined roller support or a horizontal roller support. Let us say this is another roller support. In case of analysis of trusses, we will come across a roller support like this. In that case, the reaction will be perpendicular to the roller. The reaction will be perpendicular to the roller. There can be a case in case of a truss truss support. A roller may be inclined roller. In that case, the reaction offered by the roller will be perpendicular to the roller in this particular direction. So my friends, roller support will not offer a vertical reaction always. It may offer the reaction in the direction perpendicular to the beam. So this is how roller support offers. So in all, roller support offers only one reaction, whereas in case of fixed beam, it offers three reactions. It offers three reactions, two reactions and one moment reaction, two force reactions and one moment reaction. So fixed support will offer three reactions. So three reactions in case of fixed support, two reactions in case of hinge support, and one reaction in case of roller support. Whereas free joint will not offer any reactions. Free joint will not offer any reactions. So zero reactions for free joint. Free joint is there. So as you restrain the joint by number of restraints, fixed support offers the maximum restraints. That's why it will offer three reactions. Hinge support will offer lesser restraints than the fixed support. It will offer two reactions, and the roller support will offer still lesser restraints than hinge support. It will offer only one reaction. So fixed, hinge, and roller, three, two, and one reaction. Now types of loads and their equivalents. So first type of load we generally come across is a point load. This is a point load. We indicate point load or concentrated load. We indicate by this sign, point load or concentrated load. Point load or concentrated load. It is concentrated at one single point, and that is why it may also be called as point load. This is indicated as, let us say, this point load 10 kilonewtons. 10 kilonewton concentrated at one particular point on the beam. This is called as point load or concentrated load. Another type of load we will come across in our discussions later in this particular course is uniformly distributed load, is known as uniformly distributed load or UDL, uniformly distributed load or UDL, shortly known as UDL. It is expressed as, let us say, 4 kilonewtons per meter. It is expressed as number of kilonewtons per meter. Let us say this is a beam of length 5 meters, then this is a uniformly distributed load 4 kilonewton per meter. All of you must have calculated the total effect of the load will be 4 kilonewton per meters into 5 meters, that is 20 kilonewton. This is the total effect of the load, but it is uniformly distributed. This 20 kilonewton is not concentrated at one point, it is uniformly distributed across the particular beam. This is uniformly distributed load. It can also be represented by this sign like this, a rectangle. Uniformly distributed load can be alternatively represented by a rectangle like this. This is also called as uniformly distributed load, 4 kilonewton per meter for a length of 5 meters. This is also uniformly distributed load. Now the third type of load is uniformly varying load, where it may vary from 0 to a particular value. Let us say it is varying 6 kilonewton per meter. It may vary, uniformly varying load, okay, 6 kilonewton per meter from 0 at one end of the beam and 6 kilonewton per meter at another end of the beam. Let us say the length is 4 meters. Length of the beam is 4 meters. This is also called as uniformly varying load or triangular load. Uniformly varying load or triangular load, uniformly varying load or triangular load, uniformly varying load. So if we consider the uniformly distributed load, if I want to calculate the total value of the UDL, this total UDL will be equal to 4 into 5, that is equal to 20 kilonewton will be the effective point load for this particular UDL. But instead of acting as a point load, it is acting as uniformly distributed across the length of the beam. But total effect is 4 kilonewton per meter into 5, that is 20 kilonewton. In this case, the total effect of this uniformly varying load will be area of the triangle or area of the geometric figure, half 4 into 6. So that comes out to be 2 2s are 4. So 12 kilonewton is the total effect of this particular uniformly varying load. But instead of being concentrated at one point, this uniformly varying load is varying, is changing uniformly from 0 kilonewton per meter to 6 kilonewton per meter across a length of 4 meters. But the total effect of this uniformly varying load is nothing but area of this triangle. Similarly, a total effect of this uniformly distributed load is nothing but area of the rectangle. So we can say if a geometric figure is considered as a load on the particular beam, the total effect of that particular load on the beam is nothing but area of the geometric figure. Now, can somebody tell me if a uniformly varying load is in the form of triangle like this? Is in the form of triangle like this. Let us say this is 4 kilonewton per meter at the center, 0 at the ends. This is the beam loaded with uniformly varying load, 0 at the ends and 4 kilonewton per meter at the center. Let us say this beam is of length 3 meter and 3 meters, 6 meters length and 4 kilonewton per meter. This is also uniformly varying load. This is also the case of uniformly varying load. So what do you mean by what is the total effect of this uniformly varying load? Uniformly varying load is nothing but area of the geometric figure, half into 6 into height 4. So that comes out to be 12 kilonewton. 12 kilonewton. 2 3s are 6, 4 3s are 12. Okay, so that is 12 kilonewton. 6 meter is the length of the beam. Total length of the beam is 6 kilometer. 6 kilonewton, 6 meter, and the uniformly varying load varies from 0 at the ends and 4 kilonewton per meter at the center. So this also can be considered as uniformly varying load. So we can in generalized say, we can say in a generalized fashion that total effect of any load is nothing but area of the geometric figure for the particular load. So this is three types of loads. Point load we have seen. Then we have seen uniformly distributed load UDL or a rectangular load. You can also represent it by a rectangle. And third, two types of uniformly varying load. And we have seen how to take into account the total effects of these loads. And now we are going to types of beams that which we are going to come across in our discussions in structural analysis, basics in structural analysis. The first type of beam is such that one of the ends is hinged and other end is roller. The first type of beam is one of the ends is hinged, other end is roller. This beam is called as simply supported beam. This we have seen in number of times. Simply supported beams. You must have analyzed, you must have found out the reactions of this in your mechanics course or solid mechanics course. Simply supported beam. So this is first type of beam where one of the ends is hinge supports and other end is supported by a roller. It is known as a simply supported beam. Another type of beam is when one of the ends is hinge, other end is roller, other end is roller, and the third end is free, hinge, roller, and free. This is known as overhanging beam. This is known as overhanging beam. So simply supported beam, overhanging beam. One more type of beam we must have came across in our structural mechanics or engineering mechanics course is one of the ends is fixed and other end is free. This is known as cantilever beam. This is known as cantilever beam. So basic types of beams are simply supported when one of the ends is hinged, other end is roller, that is simply supported beam. When one of the ends is hinged, second end is roller and third end is free, it is known as overhanging beam. And the third type of beam we must have came across is one of the ends fixed and other free, that is cantilever. Are these the end? No, no, this is not the end. Okay, we can have the beam where one end is hinged, the other rollers. One of the ends is rollers, and instead of being the third end as roller, let us say it is also roller or hinged, roller or hinged. It may have the fourth end also hinged, so it may be continued like this. This is known as continuous beam. This is known as continuous beam. We'll come across these types of beams in our analysis, in structural analysis. This is continuous beam. When many of the ends are hinges and many of the ends are rollers, or alternatively, that is known as continuous beam. One more concept of a beam: one of the ends is fixed and other end is resting on a roller or hinge. This may be roller or this may be hinge. This one of the ends is fixed, other end is resting on a roller or other end may be resting on a hinge. These both are called as propped cantilever beam. This is both these types of beams are called as propped cantilever beam. Propped cantilever. This is propped cantilever type of beam. So one of the ends is fixed, other end is either roller or hinge. It is known as propped cantilever. They are supported at the other end. Our cantilever beam is not supported at the other end, but our propped cantilever is supported at the other end. Now one more type of beam is fixed beam. When both the ends are fixed, we call this as fixed beam. We call this as fixed beam. Friends, remember we are going to come across these types of beams in our discussions further, and we are going to see various classical methods or other methods for analysis of these types of beams. So we have seen in this lecture types of supports: hinged, roller, and fixed, with 2, 1, and 3 reactions. We have also seen when the joint is free, there is zero reaction. We have seen types of loads: point load, then uniformly distributed load, and uniformly varying load or triangular load. Uniformly distributed load can be rectangular load. And we have seen one basic principle that the total load is equal to area of that particular geometric figure. And types of beams we have seen: when one of the ends is hinged, other end is roller, it is simply supported. When one of the ends is hinged, other roller, and one more end is just free, it is overhanging beam. Then we have seen one of the ends is fixed, other is free, that is cantilever beam. And then we have seen when number of ends are hinged and intermediate supports are either roller or hinged, it is called as continuous beam. When the cantilever is resting, that one of the ends is fixed and other end, instead of being free just like our cantilever, if it is resting on a roller support or a hinge support, we call it as propped cantilever. And when both the ends of the beams are fixed, this is fixed beams. Friends, I know this is not a complete list. There may be other types of beams also, but this is the basic understanding. This is the basic types of beams which we are going to come across in our near future for understanding the basics in structural analysis. I hope you have understood. For any queries or any questions, you can always write your comment in the comment box of the particular video. Thank you.